So our next example comes from page 253, where we've just learned a little bit more about inflection points here. So I'm going to go through this example a little quicker, and you feel free to pause the video or rewind it to kind of catch up with where I'm going on this. But essentially, we're going to go through all of the intervals of increase, decrease, max, mins, inflection points, concavity, and then graph this thing ultimately. So let's begin by taking our first derivative, find our critical points where the slope is 0, and then find max and mins and increase decreases. So I'm going to begin with a derivative, which should look something like 6x squared plus 4x cubed, and set that equal to 0. I'm going to go ahead and factor this while I'm at it. So I'm looking at taking out a 2x squared, so I'm left with 3 plus 2x. And then if I set those factors equal to 0, I should find that x equals 0 and negative 3 over 2. Those would be my critical points where the slope is 0. So begin by making a sign chart, and that's going to help us determine if these are maximum or minimum values. So remember that when you're finding slopes, that you take a point from each interval, plug it in, and see what you get. I like to plug things into the factored form because then I don't really have to multiply stuff out. I just have to see if I'm multiplying positive numbers or negative numbers, and is the result positive or negative. So check this out. If I take, let's say, f prime of negative 2, I'm going to plug in negative 2 to each of these x's. Here, negative 2 squared, that's positive. Negative 2 times 2 is negative 4, and 3 plus negative 4 is negative. So ultimately, a positive times a negative gives me negative values, and that's going to be a negative slope. Okay, something in between here would maybe be f prime at negative 1. So same idea, plugging in negative 1 gives me negative 1 squared, positive. Negative 1 times 2 is negative 2, and then 3 minus 2 is positive. So I'm multiplying two positive numbers. Overall, the slope is positive. And now let's say if I do f prime at 1, then I get something like 1 squared, positive, and then 2 plus 3 is positive again. So I've got positives twice here. And I want you thinking in your head already, what does my graph kind of look like right now? All right, so this guy has got to be a minimum point. So I've got a minimum when x is equal to negative 3 over 2. And then when x is 0, that's neither a max nor a min. Okay, so intervals of increase. Well, notice here that I've got positive, positive, so I don't need to take a union of those two sets. I'm just going to say it's increasing for everything from negative 3 over 2 to infinity minus that point where x is equal to 0. So I'd say we're increasing from negative 3 over 2 up to positive infinity, maybe union with x not equal to 0. Because again, when a slope is 0, you're not increasing or decreasing. So you could write it like this, or you could do each individual interval like that, whichever one you prefer. And then for intervals of decrease, well, that's everything from negative infinity up to the negative 3 halves. Okay, so all of our first derivative stuff, done, check. Let's go ahead and do second derivative stuff. Find our second derivative information. So again, I'm going to go back to the unfactored version of this. It's just much easier to take derivatives with power rule than with product rule. So that derivative becomes 12x plus 12x squared. Very cool. Okay, set equal to 0 to find your inflection points or possible inflection points, and then factor. I'm going to take out a 12x, and I got something like 1 plus x. So I can see that the values that make this equal to 0 would be 0 and negative 1. Okay, now this is pretty interesting here if you pause and take a second look, because one of my inflection points, that 0, is equal to that critical point over here. And so I'm kind of getting this shape in my head that I have a horizontal inflection point. That totally makes sense because I've got positive slopes and then 0 and then positive slopes again. So yes, the concavity changes from down to up, but that inflection point is horizontal because the slope there is horizontal. Okay, let's keep going with this idea though. So if I set up my sign chart, I put -1 and 0 onto the sign chart, and then I'll plug in values on either side of it and determine what those are. So f double prime at, say, -2, because that lives over here. Plug in -2 here and here. Well, that's a negative times a negative. So overall, positive. Upwards concavity, it holds water. Okay, in between -1 and 0, let's say -1/2. So double prime of -1/2. Let's plug in -1/2 here. Half of 12 is 6. 1 minus a half is negative or positive. So this guy became -6, and this is a positive. Negative times positive is negative. Okay, so concave down, it does not hold water, runs off it like a hill. Okay, double prime at, say, 1, because 1 lives over here. If I plug in 1, I get a positive. 1 plus 1 is positive, so 2 positives multiply to make a positive. So I've got concave up. All right, so our inflection points are -1 and 0, but notice that x equals -1 is just an inflection point like normal, whereas x equals 0 is a horizontal inflection point. And it's literally a horizontal inflection point because we have horizontal slope there as well. So it's an inflection point and the slope is horizontal. All right, I'm going to leave up the information below the line here and then use that to graph a really nice version of what this would look like, the original function. All right, I'm going to create a really rough sketch of what this function would look like. I'm not being careful of the y values. Guys, I want you to think, if you're trying to find y values, take those x's and plug them in up here. That's your y value. That's how you find an xy point. So if you need to be really specific about the graph, take these x's and plug them in. But I know that you can do that, so for now I'm just going to show you how to sketch it without being super precise. All right, my first minimum value is at -3/2. Which is here, right, -1.5, and it's a minimum, so it's gonna look something like this. Okay, my next critical point is at x equals 0, and remember that that's my horizontal inflection point as well, because I'm going from positive slope to still positive slope, but the concavity changes. So at 0, I don't know, it might be doing something kind of like this, okay? Actually, I'm going to move this guy down a little bit. Makes it a little easier to graph if there's more room between those. Okay. Now the inflection points, I want to make sure one of my inflection points is at -1. So I'm going to grab my purple pen. And at -1, the inflection changes. So I want to go from concave up to being concave down, and then up again after I pass that value 0. So here's what my graph could look like. It's concave up, I'm being really precise about being concave up, and then it changes to concave down, and then at 0 it changes again to being concave up, and so my function might look something like this. Again, if you need y values and you need to graph this really specifically, then take each of those numbers and plug it into your function to see where they actually live. But for now, I'm just creating a little rough sketch about the shape of what the function would look like. So there you go.